Using our simple system, we identified a new genetic pathway that regulates neuronal degeneration. We hope we can develop this pathway into a therapeutic target to develop new drugs to helpfully treat ALS patients. We use worms because they're a very powerful genetic system. Many of the genes you can find in worms exist in humans, and they're also cheap, and you can do experiments very quickly with them, so you can investigate pathways that you can't do in higher systems as easily. The major problem for many years was that people didn't know what the cause was. There was a genetic component, but what the genes were, people didn't know. But the past few years have seen recent major advances in identifying the genes, so now that we know what they are, it's much easier to come up with mechanisms and find therapeutic targets. People have been looking at these genes in the context of how neurons work anyway, but nobody's made the link directly to disease, so we're the first to do that. So this gives us an opportunity to just look at new targets. These might be useful for treating neurodegenerative diseases like ALS and perhaps others. We don't work just by ourselves because having sick worms is not really of interest to anybody. So we work closely with collaborators here who have other systems in mammals, other vertebrate systems, so we can move it from the worms to other systems systematically and hopefully within not too long a time move it to a clinical trial. That's the whole point. We're working together, all within Canada actually, to move this forward.